Okay, so here's the second video, just kind of dealing with these concepts. So again, mean, you can add up all your data points, X, divide by your sample size, right? And that is your mean. But really, it's kind of like balancing out, like if you have a bunch of numbers, like say 5, 7, and maybe, what is that, 7, 8, 9, 10, 11, 12, maybe I have, say, a 6 or something like that, right? What you're doing is you're kind of stealing from the higher to get to the lower so they all balance out. But if you add these, you would get 18 divided by 3, which is also 6, okay? So median is the middle number, all right? So if I have 5, 7, 6, I would put them in order, 5, 6, 7. The median is the middle, okay? So half are below, half are above. If you have an even number, so say you have like 30, like the age of some students, 19, and say maybe 42, and then 18, what you do is put them in order, because obviously the middle would change if you could move them around all the time. So it has to be in the numeric order. So 18, 19, 30, and 42. And then what you do is you take the middle of the middles. So I'm going to have to average these because I don't have a true middle like when you have an odd number. So I'm going to average these. So that would be what, 49 divided by 2, 50 divided by 2 is 25. So that's going to be what, 24.5. So that's my median, meaning half is above, half and below, okay? Mode is the most popular. So median is the middle, but they have to be in order. Mode is the most popular, okay? And you can have bimodal, trimodal, or whatever. So if I have like 3, 4, 6, 6, 8, the mode would be 6 because it's the most popular. If I have, say, 18, 18, 18, 19, 19, 19, 20, 20, 20, and then let's see, let's add an extra 20 and an extra 18. Okay, so I have a lot of repeats here, but I have 4 18s, 3 of these, 4 of those. This is bimodal. There's 2 modes, 18 and 20. 19 is not a mode because it's not the most popular. The 18 and 20 have more. The range is high minus the low, and you actually get an answer, okay? So like here, the highest age was 20, the lowest was 18, so 20 minus 18 is 2. Here, the range is the high minus the low, 8 minus 3 is 5. And then let's see here, 42 minus 18 is what, 24 is the range, okay? And then we have the mid-range, which is kind of the average of the high and the low. So if you take the high plus the low and divide by 2, that's the mid-range. So like here, the high and the low, 8 plus 3 divided by 2, 11 divided by 2. Okay, 12 divided by 2 is 6. This is going to be what, 5.5. That's your mid-range when you average the high and the low. Okay, now as far as stats go, I tend to like the median actually more than the average. The average can be deceiving. Like, for example, teacher salaries. Say I have some teachers and I have one that makes 40K a year, and then one that makes 88K a year, another one that makes 80K a year, and let's see, that's actually probably good. Okay, so well, maybe one more. Let's do like 78K. All right, so say I randomly get 4 teachers and this is their salary. Now again, I don't really want to steal from the rich and the poor. I just want to kind of add these up. So I'm going to add those up. And then make sure you hit enter. So I typed all those in. I'm going to hit enter. So that's 286. And then I'm going to divide it by 4 because I have 4 teacher salaries here. So that's what, 71.5K. All right. So it looks like on average, these teachers, 71,500 maybe per year. But when you look at it, these 3 people all make more than that, right? Like, it's not saying the average doesn't mean the typical teacher makes that, because actually most of the teachers make way more than that. 3 of them make more than that, okay? The problem is you have an outlier, and this one makes way less. And so if you steal from the rich and give to the poor, right, it's bringing those averages down. And so this would be skewed to the left because that low number is, the average should be higher than this if this guy was gone. If this guy was gone, the average would be much higher, right? But this guy is skewing it to the left lower, okay? So that outlier really messes you up when you do average, okay? And again, that's that one. If I put these in order, I have 40K, let's see, 78K, 80K, and 88K. Well, the median, if I put them in order, the median is the average of these two, which would be about 79K, so about 79,000. And that, seems a little more reasonable, right? These are close to 79,000. Yeah, that one's higher, but that one's way lower. So this is saying that half of the teachers made more than 79,000 a year, half of the teachers made less than 79,000 a year. That's the median. And it is not skewed by that 40,000. That 40,000 does not skew it. Because it's taking the middle of the middles, this 40 doesn't even impact it. So I tend to like medians. It's okay. Averages are good as long as you either don't have an outlier, or if you know what they mean and you're like, oh, okay, maybe there's an outlier there. All right. Let's see what else. So we did those. So make sure you know all those. All right. Let's talk about finding the mean if you have a frequency table. So maybe I have age and I have frequency. And so say this is 17, 18, and 40. And I know that I have 4 people that age, 10 people that age, and 2 here. Okay. One way to do this is, list them all out. So 17, 17, 17, 17, 18, 18, 18, 18, 18, 18, 18, 18, 18, 18, because I have 10 of them, and then 40 and 40. And what you could do is you could add those all up and divide by 16 if you felt like it, but that's kind of a lot of work. I would rather do kind of like expected value or a weighted mean. Okay, so I'm going to do more of a weighted mean, like when we did GPAs or expected value, weighted grades in the class, things like that. So this is a formula. What does it say? Take your data, which is your age, times frequency, add all those up after you multiply. So this should remind you of the video I made where we did GPAs or expected value, things like that. All right, so we're going to multiply across. So, okay, so 17 times 4 is 68. 18 times 10 is 180. And 40 times 2 is 80. And then I'm going to add all those up. Okay, so that's what this says. It says multiply the value times the frequency. Then this guy is called a summation, and it means add all those up. So I'm going to add those up, which I get, 328. And then it says divide by n, okay? So n is how many are in the sample, which is 16? So I'm going to turn around and divide this by 16. This should remind you of when I did GPAs. Oh, shoot. All right, 328. I cleared my calculator accidentally. Divide by 16. All right, I got 20.5. Okay, so that would be years old. Now, again, I could do this. The only problem with this is happen if you have 100 of them, right? So happen if you have like age, all right? So say I'm looking at DMAC and I have frequency. Maybe it's a big, or at Iowa State, I have 50 students that are 18, and then 19, I have 222 of them, okay? And my class only has 18, 19-year-olds. I do not want to list out 18, 18, 18, 18, 18, 50 times. And remember, repeat addition is multiplication, right? So like adding 17 4 times is the definition of multiplication. So I'm going to use this formula, and I'm just going to be like, okay, I'm just going to do like a weighted grade or a GPA. I'm going to take 18 times 50 and get my 900. And I'm going to take my 222 times 19 and get 4,218. Then I'm going to add those together and get, and then I'm going to divide by how many people I have. Well, that's your frequency. So that's what, 272, is that right? 272, 200, yeah, 272. All right, so that's what, 18 point, about 8, right? So the average age is about 18.8, okay? Notice it's really close to 19 because I have tons of students that are 19, right? But these 18-year-olds bring it down just a tad, but not a whole lot, okay? That is how you find the mean. This is your average when you have a lot of data and you have repeats and you can make a frequency table. All right, what do you do if the data has been organized in a chart and you kind of like a histogram, like a frequency table? So you actually don't even know your data anymore. You kind of lost it in the process. So maybe this is the temp, this is the frequency. So say we have 5, 2, and 8. This is different than up here because up here I actually knew I had 50 18s and 222 19s. Here, I don't know if these are 4, 4, 4, 4, 4, all zeros. Maybe there's a 0, 1, 2, 3, 4. Maybe there's 2 4s, a 1, 1, and a 0. I have no idea. So what are we going to do? Well, basically, we are going to find what we call the midpoint, because we're just going to average these, and we're going to look for where is the midpoint, because that's kind of the average. So if I take 0 plus 4 and divide by 2, I get 2 as my midpoint. If I take 5 plus 9, which is 14, divide by 2, I get 7. And if I take 10 plus 14, divide by 2, 24, I get 12, okay? And so I don't know if I have all 4s, all 0s, but I'm just going to assume my numbers are all the average. So this is like, I'm assuming I have 2, 2, 2, 2, right? So if, again, after you do that, if you want to write it out, 5 2s, 2 7s, and what, 8 12s? Okay, I could, now that I know what number I'm going to use instead of the ranges, I could add these up and divide by, what is that, 15? So I could add all those up and I could divide by, 15 if I wanted to. All right. But the other thing I could do is the same formula that I did up here, except I'm going to use the midpoint, right? So I'm going to do the midpoint times the frequency, midpoint times frequency, midpoint times frequency, and add up. So same as before, 2 times that gives me a 10. 7 times that is a 14. And 12 times 8, I think that's 96. Okay, so I'm going to add those up. What is that? That's 100. Is that 120? Okay, so I'll just double check because I need to divide anyway. Okay, 120 divided by your frequency. So divide by 15. It didn't like that. Oh, no, it did. 8. So 120 divided by 15 gives me an average of 8. That's my average, okay? So again, I don't know the real data if the average was exactly 8, but it's going to be pretty close, okay? So that's how you can kind of, figure that out a little bit if you need to. All right, the next concept might be in the next section, but we're going to talk, and we can start it here, about standard deviation. And what it's used for is this. So say I have, say I give a little quiz or say the temperatures. What do I want to do? We'll do temperatures, all 4. Say here you have 3, 4, 5, 4. And then say here you have 0, 0, 0, 16. And then here we have 1, 1, 1, 13. Okay, these are 4 different data sets, like A, B, C, D. All right, so if we find the average of these, right, add them all up, divide 16, divide by that, average is 4. But notice they're all 4, right? So the course average is 4. Here, I could add them up, divide by 4, but I could also steal one from that guy and give it to that and see, oh yeah, they'd all be 4. Same thing, 16 divided by 4 is still 4, or steal, give, give, give. And then here, if you add these up, 16 divided by that is 4. So the problem is the average is 4. And as a teacher, sometimes I get this with like a test, students will be like, well, what was the average? Well, okay, if I have 4 students that all got 75s, the average is 75, right? Everybody got a 75. If I add and divide by 4, I get a 75. Okay. But what if I have 100, 100, 100, and a student takes a 0 on the test? Okay. Well, 300 divided by 4 is also 75. And so the average is still 75. But these are way different. Like here, yeah, is it typical to get a C on this exam? Yeah, everybody did. That's average. But here, if I tell my students the average was 75, that outlier is misleading because everybody that took it got an A+. The only reason the average is a C is because someone took a 0 on it. So the average by itself, it just is really not good. That's where the median would be good. But we have kind of something to come to the rescue, which is the standard deviation. And the standard deviation kind of is a second measure, deviation. It tells you how they deviate, right? So I can look at here and be like, oh, that's going to, see how they all vary by 0? The standard deviation is 0, which means all the numbers are the same. Here, these vary by 1, 1, 1, 0, 2. So here I would guess the standard deviation might be like 0.9, maybe it's 1, 1.2 in that range. here, oh my gosh, like that's, the standard deviation, here it's 16, 16, 16, but then it's 0, 0, 0. So maybe the standard deviation is like 8, maybe, or 9. And then same down here.